ठीक है, ये तो हो गया। और
अभी से कौन आता है?
चलो कोई बात नहीं, एडमिट कर दीजिए। बस इसको ऑडियो वीडियो ऑफ कर दो। मैंने वीडियो ऑफ कर दिया, ऑडियो। PhD candidates and more than 30 ME candidates. So he has a very vast experience of power system teaching, and as well as using various optimization tools for power system operations. So similarly, today workshop will be focused on one such tools, GAMS, and his main teaching interests. So I welcome Dr. Ashwini Sharma for the same. You may continue, sir, because I have made you co-host. सर को होस्ट नहीं है क्या? है ना? आ नहीं रहा, आ नहीं रहा। मैं करता हूँ दोबारा ना, वो हट गया होगा। सर हेलो।
जी नेट चला गया था, अभी लाइट चली गई थी थोड़ी देर के लिए।
कोई बात नहीं सर, कोई बात नहीं, आप आराम से कर लेंगे, कोई ऐसी दिक्कत नहीं।
मैं ज्वाइन कर रहा हूँ दोबारा से।
ठीक है सर, ठीक है, ठीक है, ठीक है सर, ठीक है, कोई दिक्कत नहीं।
10 मिनट है।
हाँ हाँ सर, कोई दिक्कत नहीं, कोई दिक्कत नहीं।
पूरा हाल है नेट का यहाँ पर यार, लाइट चली जाती है देख 1 मिनट के लिए।
कोई
क्या
बात
बताएं।
नहीं, कोई बात नहीं सर, आप कर लो, आराम से कर लो। मैं थोड़ा कह देता हूँ पार्टिसिपेंट्स को ना।
हाँ 10 मिनट है, मैं आपको जैसे ज्वाइन हो जाएगा आई विल बी अवेलेबल।
हाँ, ओके सर, ओके।
ओके ओके।
So there was some electricity issue, so let's wait for 2 minutes. नहीं नहीं, मैं हूँ। There is also one announcement for all the participants. Today there was a session of Dr. Anurag Srivastava from West Virginia University. That session will be shifted tomorrow or day after tomorrow. We'll let you know through mail as well as through our WhatsApp group, because there was mail was received from Dr. Anurag regarding his flight cancellation or some issue. So he has requested that his session may be shifted either on the 16th or 17th. So whatever will be the next schedule, that schedule will share with you.
And Dr. Sanjeev, there was actually spike in a power, so net was disturbed. So I am
Welcome, sir,
available.
welcome.
Dr. Sanjeev, I am available now.
ठीक है sir. You may start. I am making a co-host.
Yeah, okay. So
Just
thank
a
you
minute,
very
sir.
much, Dr. Sanjeev, for giving me this opportunity to share some of the important information about a software called GAMS. I will give all details related to the software, what are the facilities, and some of the examples I have taken so that we can discuss. And software is very strong, and all the people, all the scholars, all the faculty members, they can make use of this software for their research work and can utilize the very good facilities available in the software. So thank you once again, Dr. Sanjeev. Now I will share the presentation, then you can inform whether it is available to all of you or not.
Okay, sir. Okay.
My screen is visible to all of you?
Visible, sir. It's visible.
It's visible?
Yes, sir.
Okay, fine. Let me go for the slideshow and then from beginning. Yeah, bigger screen is visible, Dr. Sanjeev?
Sir, visible, sir. Visible, it's visible.
Visible. Thank you very much. So thank you all. I welcome all the faculty members, the scholars, students who have joined all over India to this ATAL-FDP. I also thank organizers of this ATAL-FDP program to give me this opportunity to share some of the important information related to engineering optimization models using a very strong software called as GAMS. So these are the contents of the presentations today. We will discuss about general overview of the GAMS. What are the different model types? What are different available solvers? What is the structure of the GAMS model? And some of the examples I have solved from a book by S. Rao. So I suggest all of you to have this book and try to find out how the simple problems can be solved using GAMS. Then you can go for the bigger problems and solving them using the software. Just a minute. Okay. So what is a GAMS actually? We call it as a general algebraic modeling system. Basically, this software was developed to be used for economic problems, and it was basically utilized for the World Bank by the economists. However, looking into the very strong features of this software, now this software is available to all the universities around globe, and many engineering scholars as well as the other non-engineering side, they are utilizing this software for the solution of the problems, very complex problems. One of the best feature of this software general algebraic modeling system is that we can solve simultaneous nonlinear equations with or without any objective function. Some of the very important features are that it is very simple and equations can be written in a very simple way. So implementation of the software is very simple. There is a very good possibility of probability and transferability between the users and systems. We can link this software with different other softwares as well. The transferability of the software is very strong. Like we can have a interfacing with the MATLAB. We can also have interfacing with your other files like Excel sheets. We have also the facilities to interface this with other software like PSAT, or we can also link it with the sim power of the MATLAB. So a lot of facilities are available, which gives a very good feature of transferring the data from one platform to another platform. Then very easy to have a technical update available. You can also download it. It is freely available, but it will be for simple, I think around 15 node system you can solve. So freely available in the website, but if you want to have a very big problem solving using the GAMS, then you need to procure it. We have a very strong GAMS ID interface, okay, and this is basically a very strong general text editor which is compatible with Windows, and it offers a very good facility and ability to launch for the compilation and execution of the different programs which are written in GAMS. So this lecture today will give you the basic structure of GAMS program. We will have a detailed illustration of some of the examples. Then how to write a code that we will discuss. This gives you very important information about the general algebraic modeling system. And what are the key components here? We have to give the input file in a model, which is essentially required. This input file can be there already in a GAMS, or input file you can also take as a text from other platform also, like from MATLAB, you can also give input file. You can give input file in, as a .int extension. So once you start using slowly you will learn how to give an input file. I'll take up an example, taking the input file in terms of different formats itself in a GAMS. However, there are other facilities to give you input file. Then we have a GAMS compilation of the model which you will design, writing the equations, the objective functions, then the constraints, linear and nonlinear both. Constraints may be utilized in the form of the upper and lower bounds. So once this model is ready in GAMS, there is a facility to call different kind of the solvers. There are a lot of solvers. I'll talk of these solvers briefly, which are utilizing the different techniques to solve the problems. Once you are calling a solver, then the problem will be solved and you can transfer the output files as a result. You can display the results itself in a GAMS, or if you are doing the interfacing with the MATLAB, then the results can be transported in terms of the Excel sheet that can be taken in another platform, or you can also transfer the data of this output file to the MATLAB. So you can have you can utilize the feature of the MATLAB to plot or to analyze the data in different platforms. So GAMS code writing is very simple, and once you write this code, this will be with the extension of .gms. So all the programs which you write in GAMS, they will appear with the extension of .gms, like load.gms, yeah, economic load.gms. If you're writing a program for economic load dispatch, so this will appear like a eld.gms. And once this program is ready, then we can run it in a platform of GAMS. Then you will get a very important file which is called listing file, .lst. This listing file gives you the entire information what you have written in a program, like what is the all equations listing that you can get in a listing file. We will have all kind of information with the upper bound, lower bound, constraints, all listing will be there. This will be available as a model statistics. This model statistics will give you very important information. If any kind of problem is there in running a GAM, like there is a logical error or there is another kind of error, or you are not getting a solution because of some problem. So listing file will give you where is the error. So finding an error is very, very simple, like in MATLAB. So once you find out these errors, you remove the errors, then again run the program, then you will get a solution. So you will get a very important solve summary. This solve summary will give you different kind of information like marginal values, level values, objective function value, or whatever the equations you write in GAMS, the detail of all these equations you can get in a solved summary. So once the program is ready and you run it, it is running successfully without any error, then you can get your results. And these results can be interpreted in different ways. So this was a brief of the GAMS and the facilities available. Now, once you start writing a program and solving the optimization problem, it is very important for the user to identify what kind of problem you are solving. Until and unless you understand that what kind of problem you are solving, it is very difficult to call the solvers. Because we have different types of the solvers available inside, you have the options to select the solvers. And many solvers have the different facilities to solve the optimization problems. Therefore, it is very important to understand the different nature of the problems. So first of all, let's take a linear programming problem. So what is a linear programming problem? You can take a book by C.S. Rao and try to understand that how a linear programming is defined. So linear programming problem looks like this. It will be a minimize or maximize Cx, which is subjected to constraints like Ax less than b, where x variable is defined with certain lower and upper bounds. So the problem of this nature is called linear programming problem. So x is basically a vector, okay, which is a continuous real number. We call Cx, okay, as an objective function. Ax, which belongs to b, is a constraint basically. This constraint may be having the less than equal to or equal to or greater than equal to operators. So we can have wide variety of the equations which are giving you whether it is a less than equal to some parameter or greater than some parameter or equal to certain parameter. L and U are upper bounds, okay, which are between 0 and infinity, or some bounds will be given to you in a problem. So we can select those bounds while we write the linear programming problem. Second is nonlinear programming problem. You have to identify it. When objective function can be linear or nonlinear, your constraints may be linear or nonlinear. When there is a combination of linear or nonlinear, or it is a combination of the nonlinear elements, we call or we define this kind of problem as the nonlinear programming problem, which is we are minimizing or maximizing a objective function fx, which is subjected to the constraints gx, okay, belonging to certain parameters, and this x variable is between certain lower and upper bound. So we call this kind of problem as nonlinear programming problem. Then there can be the mixed integer programming problem. So in many solution of the problems, we came across the mixed integer, like in electrical engineering, when we are placing a certain device, that may be a capacitor banks, or that may be the reactor, or that may be the capacitor, or that may be the combination, like FACS devices. So where to put these FACS devices? We define such kind of problems by using the mixed integer, like 1 or 0. If device is available, this will be a 1, or if device is not available in the system, we can give it as a 0. So this kind of problem key is identified as mixed integer programming. So this programming looks like this. Okay. So the variables, the t, u, v, w, x, or y, or z in this objective function, which you are maximizing or minimizing subject to certain constraint, these all variables are basically certain sets. Like it may be a pure integer 0 or 1. There may be certain sets like special order set of type 1, special order set of type 2. Okay. What are these special order sets? This is certain way to restrict the number of non-zero solution values. So while you take up a problem from S. Rao, you will understand that what are special order sets. So in certain equation, we can have special order sets of type 1. Type 1 or type 2 will be categorized based on the restriction of number of non-zero solution values, or what are the special values you are taking in terms of that may be non-zero. There may be two variables which are non-zero in a adjacent set. So this special order set of type 1 and type 2 will be defined actually in a problem. So this kind of problem where we have integers, or where we may have a special order sets of type 1 and type 2, this kind of problem can be solved as a mixed integer programming. So we have a solver available, very strong solver like Cplex, okay, that can be utilized to solve mixed integer programming problems. And especially in the problems of power systems, we have many devices which need to be connected in a system, and their presence or absence can be decided in terms of the special order sets, or it can be decided in terms of mixed integer variable. Another kind of problem may be mixed integer MINLP programming. So mixed integer NLP programming looks like this. So we have a objective function fx plus dy, which is subjected to the constraints defined by this equation. The x variable is between lower and upper bound. This by parameter that can be a mixed integer or special order sets. So this kind of problem we call as a mixed integer nonlinear programming problem. There can be a optimization problem where we have a function which is not continuous. So these kind of problems where continuous set of equation is not available, or which is having a derivative, which is not having a derivative under certain sets, or which is discontinuous, like absolute function. So this kind of problem can be identified as a discontinuous derivative problem, and we call it as DNLP. So many problems like min-max problems, min-max functions, where we don't have a continuous derivatives available. These kind of problem can also be solved in GAMS by calling a certain solver, okay, which is called DNLP solver. So the problem looks like this. We have to maximize or minimize fx subject to the constraints. X is a variable between certain lower and upper bound. Okay, gx represent the constraint which may have the function belonging to non-smooth functions, or objective function may also contain like non-smooth functions which may be absolute, min, or max. So this kind of problem is identified as DNLP problem. In addition to this, mostly in power system network, we have the LP problem, NLP problem, mixed integer LP problem, or mixed integer non-NLP problem. Mixed complementarity problem generally we have in some other areas, but they can also be solved. Like we have to find a value of z, okay, such that my function is satisfied within certain lower and upper bound of the variable z. So in this complementarity problem, we don't have any objective function, but we are solving a certain function, finding out the values between certain upper and lower bound and satisfying this function. So this kind of the problem we call it as a mixed complementarity problem. Okay, so mixed complementarity problem can also be solved with the help of GAMS. There are certain issues. Sometimes we have a very complex problem where we are not able to find out the integer solution, but the solution is coming out to be like instead of 1, it is 0.9999. So under such situation, okay, 0.9999 can be taken as a 1. However, to solve such kind of complex problems where exact value of 1 is not available, so we can get a solution by relaxing it. So this is called relaxed mixed integer nonlinear programming problem. So this kind of the problem can also be solved where we are not getting exact integer solution, but solution is very near to the integer value. So there is a facility in GAMS that we can relax it, and we can call a certain function available in the GAMS software where we can relax the mixed integer variables. So this is called relaxed mixed integer nonlinear programming problem. This can also be well solved. Okay, as an example, like we have a very complex network of nodes, maybe more than 500 nodes in a power system network, and we are placing the FETs devices. However, solution is very complex to obtain because the number of the equations are very, very large, and getting a solution of the placement of device at a certain bus or at a certain node or between the lines, we are not able to get the exact value of 0 or 1. However, they are very near to 0 or 1. Such kind of the problems we can solve by calling the relaxed mixed integer nonlinear programming. Similarly, we can have constrained nonlinear systems. Okay, so I ask all of you to follow the book by S. Rao. All these problems are given, and you can easily identify that what kind of the optimization problem you are going to solve. However, constrained nonlinear system problem is also it can also be solved by using GAMS. Okay. Similarly, mathematical program with equilibrium constraints, MPEC optimization problem we call it. So MPEC problem look like this. Try to identify these problems. Okay, and this can also be solved by utilizing the GAMS solvers. So I talked about in this part of the presentation, what are the types of the optimization problem you are going to solve. So it is essentially required that while you utilize the GAMS software, first of all, you must understand what kind of optimization problem you are going to solve. And until unless you have an idea that what kind of problem you are solving, it is not easy to call the solver, because different solvers are solving different kind of the optimization problems. So now onward this slide, what are the basic solvers available inside the GAMS? You can have just a look. Okay, so in a GAMS software, we have one of the important solver, Baron, which is based on branch and bound optimization algorithm. Baron is a very important solver. Okay. Similarly, we have BDMLP solver, which solve LP problems. We have Bench. Okay. We have Quinor. We have Conopt solver. We have Convert solver. We have Cplex solver. We have Decis solver. We have Decopt solver. So this is an entire list of the solvers available in a GAMS. There is no need to procure all the solvers because some of the solvers, they are common. Okay, and they solve similar kind of the problem. So we don't want to have all the solvers to solve the problems of an LP like LP or NLP. Some of the solvers can be procured out of this to solve the problem. For example, Conopt solver will take you NLP. Similarly, SNOPT solver is also there. This SNOPT solver is also solving same kind of problem. So out of these two, you can either opt Conopt or SNOPT. Okay, both are very good. Like Cplex, which is a LP or MIP solver. Decis, okay. Decopt solver is also very important, which is solving MI NLP problem. So these all solvers which are available in a GAMS need not to be procured all the solvers because it will be very costly. So at NIT Kurukshetra, we have procured Conopt solver, Cplex solver, Decis solver, Decopt solver, okay, Lingo solver for global optimization, Lindo Global we have procured. We have a Mosaic solver. Similarly, we have the AICTE solver. So out of this solver, what will be your choice? So you can get a brief idea and the strong features with software solvers. Accordingly, you can decide that which kind of solver you want to procure. However, this is a wide list of the solver which can be utilized to solve similar nature of problems. So this window you will get information which solver is fully available. So BDMLP is fully available. Similarly, this information will give you which solver you have procured actually. So if they are not full, you will get a cross. If they are full, okay, you will get dot information. So which solver you have as a full version that can be easily understood from the software. Some of the idea I'll give you what is a baron, just to give you an idea that why these softwares or why these solvers available are different. However, these solvers can solve the same kind of the problem. So baron is a solver which is giving you global optimal solutions for non-convex problems. Basically, baron is developed by Synedis and Tavermelanin. So this is basically a solver developed in the University of Illinois, baron solver. Okay, so this can solve continuous, purely integer, mixed integer types of the problems can be solved. This baron is a very strong software which is based on a concept of branch and reduce optimization. So we call it as a branch and reduce optimization navigator. So what is a branch and bound method to solve the optimization problem? You can take a book by S. Rao. Try to understand what is branch and bound algorithm. So the concept of the branch and bound algorithm is utilized in GAMS. So it is very strong, which can solve LP, MIP, RMIP, NLP, DNLP, relaxed mixed integer, or mixed integer NLP. So these all kind of problems can be solved by baron. Similarly, BDMLP that can solve LP and MIP. So once if you procure this baron, there is no need to procure BDMLP because this is solving LP MIP, which is already taken care by the baron software. Okay, so this is a second kind of the solver available. CONOP solver is very strong, which can solve linear programming problem, relaxed mixed integer programming problem, NLP problem, CNS, DNLP, RMNLP. All these can be solved by CONOP solver. And this CONOP solver, if you look at the basic structure, this is based on sequential quadratic programming. So what is a SQP? You can find out how SQP can be utilized. So take a book by Rao and study about the sequential quadratic programming approach. CONOP solver is utilizing this approach for the solution. Cplex is also very strong, which can solve linear, your quadratic and mixed integer programming problem. Cplex is also based on branch and bound algorithm. But this Cplex solver can take into account the integer variables. This also takes into account special order set of type 1 and special order set of type 2. So very strong Cplex. You can also procure Cplex. DCOP solver is also very strong, which was developed by J. Viswanathan and I. Grossman at Malone University. Okay, this DCOP solver basically solved the optimization problem where we do not have the continuous derivative function like absolute min max function. So DCOP solver can solve that. Minos is also very strong module available in the GAMS, although we are not procured at NIT Kurukshetra because this is solving basically LP, RMIP, NLP, DNLP and RMINLP, which is taken care by baron. But if you see the features of this Minos, this is based on a reduced gradient algorithm with a combination of quasi-Newton algorithm. So you can compare the baron methodology for solving the optimization problem, Minos methodology to solve the optimization problem. You can compare which one is better. So accordingly, solution will be similar under both the solvers. However, there are certain features which Minos are using. Okay, so this is combining a reduced gradient approach with quasi-Newton algorithm. So this is also very strong solver available in the GAMS. Another is software package by Mosaic. Mosaic is also solving linear, mixed integer, linear, quadratic, mixed integer, okay, quadratically constrained problem, convex, nonlinear optimization problems. And Mosaic basically developed by Erling Anderson. So these all your modules are named after the mathematicians or scientists like Erling. So this is a Node Erling software, SEK. they were developed by these scientists. Okay, so Mosaic is also very strong, which can solve LP, MIP, RMIP, NLP, DNLP, and RMILP. Okay, so these all features are also available in Baron, but it is based on interior point optimization method. So interior point is having its own beauty of solving the problem. So conic interior point optimization with conic quadratic problems can be very beautifully solved by Mosaic. So try to understand what is the interior optimization algorithm, conic interior optimization algorithm, what are their features. Everything is explained in book by S. Rao. This SNOP solver is also very good, which is developed by P. Gill at University of California, San Diego, W. Murray and M. Saunders. Okay, so we call it as a SNOP solver. SNOP solver can solve LP, RMIP, NLP, DNLP, and RMIP, RM, mixed integer nonlinear programming. So SNOPT and CONOPT basically are similar. This is also based on sequential quadratic problem. Okay, which uses augmented Lagrangian merit function. So you will find a difference in the methodology for CONOPT solver, which is based on sequential quadratic programming, SNOP solver, which is based on the sequential quadratic algorithm, but using the augmented Lagrangian function. So what is the advantage? You can get a solution faster, and the SNOP can solve very complex nonlinear programming problems of a large number of the variables. So it has its own beauty. So you can also think of procuring the SNOP solver. Similarly, we have MILES. Okay, mixed complementarity problem, generally not used for the power system people. So we have not procured MILES. It's not required for, especially because we have convex kind of problems which can be solved by the SNOPT, CONOPT, DECOPT, DNLP solvers. OQNLP is also very strong software. Okay, which give a global optimal solution of nonlinear programming problems, also mixed integer nonlinear programming problem. So OQNLP we have procured, which generally we utilize, students are utilizing it solving the integer programming problems. So OQNLP is, we call it as a global optimizer. So very strong. Similarly, we have SBB solver, which is similar to CONOPT and SNOPT. So it is your choice. This also takes into account the integer, semi-continuous, semi-integer, special order set of type 1 and type 2. AICTE is also a solver which solve the linear and mixed integer programming problems. Okay, AICTE is based on primal simplex algorithm, dual simplex algorithm, and interior point barrier algorithm. So you can make a comparison of AICTE and SNOPT, how these techniques are compared. So accordingly, they have their own capabilities to solve the problems. However, AICTE is also utilizing a very sophisticated optimization algorithm to solve the problem, especially LP, MIP, and RMIP. So we have also procured AICTE at NIT Kurukshetra. LGO solver, which is a continuous global optimizer solver, we have procured at NIT Kurukshetra, LGO, okay, which is a very strong software to solve and finding out the global optimal solution for problem of LP, RMIP, NLP, and DNLP. This is based on branch and bound, but it is having an adaptive feature to search the global optimal point. So adaptive global random search algorithm is utilized by the LGO solver. Okay, so you can get the important idea about how the algorithm is utilizing adaptive global random search to find out on a certain platform what is the global solution, optimal solution for the problem. This software is very strong, LGO. Lindo Global, we have also procured Lindo Global. Lindo Global is also finding out global optimal solution to nonlinear programming problems. Okay, And this is also employing branch and bound algorithm with Gomori cuts. So what is this mathematical technique of utilizing branch and cut methods? You can get an idea from the S-tau. So you will find out that Gomori cuts are very giving you a very good solution while we have a very complex nonlinear programming problem or mixed integer programming problem, finding out a global optimal solution within a search space. So GAMS into global is a very, very strong solver available in the GAMS. So that's all. I discussed very briefly what are the different solvers. How will you choose these solvers to procure specially at your place? But you need to find out that what are the algorithmic steps utilized for finding out a solution. What are the beauty of the algorithm? So once you have this kind of comparison in your mind, you can find out that what kind of the solver you need for your problems to solve. So this was one part of the presentation. Now next part we will go for the programming part. So in a GAMS, we have certain very, very important features that need to be understood. One is we need to define indices. Basically, indices are called sets. So everybody has studied about set theory. Okay. So set theories are utilized in GAMS to define the indices. Then we have the data, which is called as a parameter. So we can give data in terms of the parameters. Data can be a scalar, data can be in a tabular form. Okay. Then we have decision variables, upper and lower bounds. Then constraints and objective functions can be written in terms of equations. So these four are the very, very important part of the GAMS. Then certain general rules which is utilized as a syntax. So you can understand once you start using GAMS. Okay, GAMS does not identify it as beauty that capital and small letters are not distinguished. So you have a facility of using capital letters or small letters. This is your choice. These are the signs for multiplication, subtraction, addition, division, exponent. We use sum. Okay, sum function, product function, absolute function by ABS, exponential function, EXP, logarithmic function, LOG, maximum and min, MX and min. So these are the syntax which you can use for defining the objective functions as well as the constraints. Now you must understand what is the structure of GAMS and how the GAMS programs can be written. So GAMS basically is a collection of the different statements in terms of objective function, in terms of the constraints, in terms of the bounds, lower and upper, which is to be translated in terms of the syntax of GAMS. So once you started learning, within 4 or 5 days, you will be very good conversant with the how to write out the GAMS programs. However, you have to define it in a certain fashion. So documentation is very, very important while you write the program. First of all, you try to understand what kind of problem you are solving. Then you do the documentation first. Then you translate this documentation into the GAMS language. So it will be very easy for you to learn. This is how the basic components of the GAMS look like. So first of all, you have a sets declaration. You can define set 1, set 2, set 3, or you can define sets. In a sets, you will declare, okay, you will assign the members. Then we have data. Data can be given in terms of parameters, tables, and scalars. Okay. Then we have variables. Declaration of the variable is essential. Okay, you will always declare which kind of variable. You can name them. Better way is that you name the variables. So it will be very easy to identify in the equations. So variable declaration and assignment of the variables. Then you have the fourth one, assignment of the upper and lower bounds. That is optional. But if you give lower and upper bound, it will be it will take a lower time to solve the problems. Otherwise, it will find a feasible solution. Okay. So upper and lower bound give you faster solution in a GAMS. Then we have equations. So you can declare the equations. These equations are basically objective function, equation of the objective function, equations of the equality constraints, equations of the inequality constraints. So once you have defined sets, data, variables by declaring each and every variable, you have assigned the upper and lower bounds, you have written the equations in terms of the GAMS syntax. Now there is a third step for model and solve statement. So this model is a very, very important statement in GAMS. By calling this model statement, what kind of problem you are solving, this model will make a combination of the objective and constraints in terms of its important equation. Like as an example, for example, you solve economic load dispatch. So you have a objective function of solving minimization of the fuel cost function subject to equality constraint. So this model will make these equations in terms of a Lagrangian function, and will also take the derivatives of the Lagrangian function. Okay, will apply the Kuhn and Cross conditions inside by utilizing the solve statement. So model statement will model the entire Lagrangian function and its derivative equations. Solve statement will solve the entire equations to find out the solution. So this is an inbuilt feature in the GAMS. So you need not to write the equations in terms of a model. It will automatically model the equations, and solve statement will solve it. This solve statement will have an option here. What kind of solver you want to use? Okay, like LP solver or NLP solver or MIP solver or MNLP solver. So what kind of problem you have already defined? Okay, and this solve statement by calling the solver will solve the problem. Then if the entire equations you have coded properly, there are no errors, then you can display the result. However, while you run this program, there is a listing file which will give you entire information. If there is a problem, it will show you where is the problem. So slowly you can remove, and finally the solution will be obtained. Then you can display the result by using the display statement. So these are certain important information: eco-print, reference maps, equation listing, status report, results. All this we will get in a output. Okay. So now these two are very important. Creation of GAMS entities, which involve two very important steps: declaration and assignment or definition. Assignment or definition in a specific value or form. So these two things you need to take care while writing the GAMS. I'll take examples how to follow these declaration of the and assignment of the problem. So now whatever we have discussed, very important features of the GAMS, that can be categorized into three different stages. Okay, in a stage one, we have sets declaration, which is essentially required for the GAMS, parameter declaration and definition, data assignment in terms of table or scalar. Then intermediate displays. If you want to have a display intermediate to see the data, whether you have entered correctly or not, you can also utilize the intermediate displays for the data. In a stage two, now this is a model formation. So you will declare variables. Okay, there may be a set of variables which you need to find out. Then we will declare the equations. There may be n number of equations. So you can give name to the equations, like equation 1, equation 2, equation 3. What is equation 1? You can name it. Then once the equations are formulated, okay, then we are calling a model definition. So I talked about the model. Model statement is very, very important, essentially required for the modeling of the entire equations in terms of the certain sets to solve it by the solver. So automatically model statement will do it. Then in a third stage, once model is ready, now you have to call a solver, which is called solve statement. So once your solve statement is called, you have an option to select different kind of solvers. So whatever solvers are available with you, you can select them. Okay. Then if coding is correct, you will get a optimal solution. You can display the results or you can transfer the results to other platforms as well. Dr. Sanjeev, am I audible to all of you?
Yes, sir. Yes, sir. Audible.
Yeah, thank you very much. Because I'm not able to see you, all of you. So you can ask a question in between. Otherwise, we can have a few questions in the end. So now to write a program, the one of the best ways that you must always give a comment. Whether you code in a MATLAB or in any language, you always give a comments. Comments give you what kind of problem you are taking. Okay, so you can declare the statement of the problem, from where you have taken the problem. Okay, and which technique you are going to utilize, you can inform in the statement. So statement can be written with a symbol star. With a symbol star. Statement can also be written on text and off text. So $on text, you give a statement like, for example, economic load dispatch problem. You are taking this problem from a book by Wood and Woolenberg. You can also refer that page number or whatever is the problem you are taking. So between on text and off text, you can give a comment. This is one of the very good way to write a program. Then general information or declaration, you can give declaration. You can declare the values to the stated parameters. So you have to state the parameters. There may be n number of parameters. You have to define parameters. Okay. For example, in economic load dispatch, you have to define what is A, constant A in a fuel cost function, constant B in a fuel cost function, constant C in a fuel cost function. Okay. So you can declare. Similarly, definition, you have to give the definition of the all the equations. Definition is very important. This will make you understand what you are going to write, what are the equations, okay, and what these equations will ultimately give you in terms of the level values or marginal values. So definition is very important. Then various terms and symbols which are very important and reserved, you should not use it. Okay, these are the reserved words utilized by the GAMS. So if you use these reserved words in a equations, there will be a confusion. So it will give error. So as you start using the GAMS, you will understand very clearly that what are the reserved words. I have shown somewhere like this. These are the reserved words which we don't use in the equations. राजू जी मेरी लेक्चर चल रहा. Similarly, these are the reserved special combination of the symbols: less than, more, not equal, arithmetic. So all these symbols are basically the special combinations which are reserved. Similarly, we have different symbols which are specially used for GAMS. So this should not be replicated in the equations. Otherwise, there will be the error. So one of the example, like you can define sets like this. Okay, set is a year, sets T is a year. So you are taking 1965 to 1999. You can define this as a set. So this is how you can write between the slash and semicolon in the echo off. We call it as a echo off. This is essentially required. Okay. So instead of giving all the values, you can write it as sets T year 1965 star 1999. So this will automatically take 65, 66. It will increment it by 1. So instead of writing large number of the values here from 65 to 1999, you can simply write 1965 to 1999 with a star. So this is basically this kind of set. So this is a better way to write sets. Similarly, you can have not only one set, but you can have a number of sets. Like one set as a station, you are taking number of stations, 4 stations. In a set J, you are taking another kind of these stations. Okay. So alias statement is very, very important here. Alias K and J. So K and J are same numbers. Okay. So alias statement you can use to define 2 variables K and J, which are equal in number. Like K station 1, 2, 3, 4. There are 4 stations K. J is also 4. So K and J are basically alias. So you can take alias statement, which will have the declaration of the other sets taking same number of the values. So you can define sets by number, you can define sets by name. GAMS take it very nicely. Okay. So you can have a different kind of the sets defined like set 1, set 2, set 3, or you can define sets. These all are sets. So how many sets? 1, 2, 3, 4, 5, 6. So in a sets declaration, there are 6 sets and each set is having the certain numbers. Then operation with sets. You can also do operation with sets with the Boolean variables. Like we can have subsets. As in a set theory, you very well know how to write the subsets. Okay, set can be written as a part of the subsets. So subsets combination can give you a new set. This facility is very, very important, and we can define large number of the subsets in a set. So once you start using sets and subsets in a small problems given by S. Rao, you will be very good conversant with writing the programs. So likewise, a very, very important property of the GAMS, we can have a different combination of the sets as a structure. Like I can write set like this. If I write the set like this, this has a meaning that it is a combination of F, B, and C, F, B, and D. So writing the set in this form means this. Similarly, you can have different combination. So if you have this kind of the set declaration, this means we can declare the set like this. So there are various ways and various structures to write the sets. We call it as a multi-dimensional set. So multi-dimensional is a very, very important feature of the GAMS. So in solving a matrix, you can have a matrix of row and column. You can have a matrix with 3 dimensions. You can have a matrix with 4 dimensions. Any dimension can be solved by the GAMS. So this is one example of the set declaration. Okay, like this is a problem. We have 3 plants. These are the shipping distances from these 3 plants to different cities. This is the items to be supplied. So how many sets are there? One is a plant set, another is a city set, market. So identifying this problem, there are 2 sets here. One set defines the plant where they are executed, where they are located. Another set defines the 3 cities. So once you understand the structure of the problem, you can define the number of sets. So these sets can now be given can be named by I and J. So I is a 2 basically number. There are 2 plants, Seattle and San Diego. J is 3 market. One is New York, another is Chicago, third is Topeka. So likewise, you can define the sets. So this is how we can declare the different kind of set. This is another example. Set is a time period 1991 to 2000. This means 91, 92, 93, 94 up to 2000. There are m number of machines. Machine 1, machine 2, machine 3 up to 24. Basically, this is a 24 in number. So by writing star, okay, this will identify it as a in the form of increment and give you the number of the values in a set. So alias statement I talked about, it is very important, and alias statement gives you the flexibility to be utilized in a set of equations. I'll take up an example later. Now once set declaration is done, second step is to declare tables or to declare the data in the form of tables. Okay, so you can declare the data now. So this is a data. This is a parameter. AI is a parameter. AI is giving you capacity of the plant. This is called declaration. So AI is a variable. AI is a parameter which is dependent upon I, which gives information about capacity of a plant. So capacity is in this data 350 and 600. So you are declaring it that there are the two plants where capacity is this. Similarly, you are declaring another parameter as a data. This data has to be given in slash. And once you have written the parameters in terms of this data in terms of parameters, finally you can close it by using this sign. Okay. So this is a one form of data I talked about. So parameters AI, parameters BJ. This data can be written in terms of scalar. This is a one data. Okay. So this is how you write a scalar data. This is a tabular data. So table is having a row and column. I is a your plant, J is the city. So plant and city can be related by a tabular data. So you can give the distance data from the plants to the cities by this table. So this is how we write the data in terms of a tabular form. Basically, this is a matrix. Like in a MATLAB, you write a matrix with column I and J. You are writing the tabular form of data in terms of matrix. D is a matrix, and D refers as a declaration, distance in thousands of miles. So declaration is very important here, which makes you very clear about the problem. So tabular data you can give like this. So this is a parametric data. You can give parametric data in terms of this. You can also give a certain equation in the parameter, which will calculate the data automatically. For example, Cij is already some parameter Cij, which is dependent upon Dij and F. So if you define F, Cij, it will automatically calculate Cij. So you can also give data in the form of parameter defined by a equation. That facility is also there in a GAMS. So likewise, these are the variables. Now third step is variables. So variable is what you want to find out. You're finding out Xij, shipment quantities. Z is basically the cost, objective function. So there are two definitions of the variables here. One is X, which is dependent upon I and J, and Z is a objective function. So these variables need to be declared. So declaration of this statement is very important. Positive variable, negative variable, you can declare which variable is positive, which variable can be a positive or negative, you need to define. Once it has been done in the form of data declaration, now we come to the equations. The next step is equation. So we will write the equation. For example, the problem which we have taken, we have three equations here. So these equations you will identify based on the problem statement. So if you clearly understand the problem statement, the equations can be easily written. For example, you want to find out the objective function, which is a cost. You want to find out what is the supply taken from the different your factories. Okay. So supply is also a equation. Demand, what is the demand of the market? That is also a equation. So these are the three equations. How many equations you need to identify very clearly from the problem. So problem statement will give you an idea how many equations do you require. So there are three equations here in this problem. So we will write now how to write the objective function. Okay, for example, you want to find out sum of xij for a j variable. So this can be written in terms of GAMS like this, sum. We are calling a sum function. So sum j is a variation for xij. So you do write this objective function by sum function. So now this is a product of two sum function or sum of two function. It can be a product, it can be a sum. So you can write the objective function in terms of the sum or in terms of the product. So this is the way to write. Like there are two sum here, sum over I, sum over j, Cij, Xij. This can be translated like this in a GAMS. So there can be a product of two quantities. Like this is a product Xij over j. So you can write product function. Understood? So this is the equation definition. So we have defined number of the equations, domain I or j. Okay, domain restriction condition is conditional, that is your choice. This symbol is very important. While you write equation, you have to write this symbol, like cost is equation, z is a z defines that cost, which is equal to sum of this. Supply is also equation, demand is also equation. So these equations have been translated as defined by the problem and exactly translated into the GAMS syntax. So slowly you will learn how to write down the equation in terms of the syntax. So three equations which are well defined, declared, and they have been written in this form. But this symbol is very important here. So less than equal to or greater than equal to, that will be the relationship of the equations which you can write. Now, once all equations have been written, next step is to model. So we will call model, what is the name of the program? In between slash all equations. You can write equation 1, equation 2, equation 3 here, but that will take a time. You can say that specific parameter for the GAMS. So you will not use all in a equation somewhere. So model, name of the program, all. So this is how we will write the model all equations. So model transport, you can also write like this. There are three equations, cost, supply, demand, as I talked these three. So instead of writing three, you write it by all. So better base, this will take into account all the equations. Now once this has been done, next step is solve. Solve, name of the program. Using LP minimizing Z, this is essential. You have to write it. Solve, name of the program, using linear programming minimizing Z. This is a solve statement which is essentially required for all kind of problem to be solved in a GAMS. If it is NLP, called NLP. Okay, likewise. Then we have a display function. So we are calculating X level value, X marginal values. So we can got it in a display function. Then upper and lower bounds you can also use. Okay, I'll take an example to show you how to write a code. So this was the basic philosophy to write the program in a GAMS. So if you have understood it very clearly, we will translate it now to certain examples. Yeah, this example I have taken from a book by S. Rao. So I request all of you to be a beginner of the GAMS. Okay, try to first of all understand the basic nature of the problems. Take certain small problems from a book by S. Rao and translate exactly into the GAMS. Okay, so one problem is minimize Z, which is dependent upon three variables x1, x2, x3, and subject to this constraint. Subject to three constraints. Okay, and x1, x2, x3 are positive variables. Their values are also given. This is a objective function. These are the constraints. These are the bounds. How to write it in the GAMS now? Initial point of start you can give. If it is given in a problem with initial start, otherwise there is no need. Initial start if you give, then you will get a very fast solution utilizing the GAMS solver. Otherwise, there is no need to give initial starting point. If it is given, if it is known to you, you can give a starting point. Okay. Now, this equation of constraint can be written as x2 minus x3 greater than 0. So this can be translated to this. Instead of writing this, we can write this equation like this. Okay. So to avoid the division by 0, it is better way to write like this equation. This is a program which is modeled now. I will run this program in GAMS also. It is available. Okay, I'll share. So these are the statements. This is the example from where it is taken. Okay. Now, if you see this problem, how many variables are there? Anybody can tell me how many variables are there in this problem? 3 variables. 3 variables. One more variable is objective function. So x1, x2, x3 are variables and z is also variable because we want to find out the value of z. So there are 4 variables here. x1, x2, x3 are positive. I am declaring them because we have given the data here. Here, this one. So from this we understood that this is a positive variable. So we are declaring that this is a positive variable x1, x2, x3. How many equations are there? How many equations? 1 equation, 2 equation, 3 equation, 4th equation. So there are 4 equations here. 3 are the constraints. 1 is the objective function. So constraint 1, constraint 2, constraint 3, these are written in terms of the syntax of GAMS directly. x2 minus x3 is greater than or equal to 0. x1 minus x3 greater than or equal to 0. Directly they are translated. This one. This is a constraint 3 and objective function. This is objective function. Now you are given the upper and lower bounds. So we will always write x1 dot up. Up means upper bound, which is 533. This is a data. 533. These are upper bound. Lower bound is 0. Lower bound, you can also define x1 dot low 0, x2 dot low 0, x3 dot low 0.
Sir,
Otherwise,
there
you
is
need
small
not to define.
request. We have to wind up by 11:50 because from 12 we have another session.
So Sanjeev, how much time is there with me?
5 minutes, sir. 5 minutes.
5 minutes only. Okay. So now everything is defined here. We have a model statement. Then we have option statement, limit row, limit column. This is a certain function which you will learn with subsequent time. However, no need to utilize it here. Model then solve statement by using a test, model test using NLP minimizing Z. This is a main program written in the GAMS. So I have shown this how they are linked with the syntax as a example. Okay, this is the solve statement. So similarly, we have taken other problems. Now, Sanjeev, can I show the GAMS software and how to run it?
Yes, sir. Once, sir.
Yeah. This is also a problem which is designed from the Rao, which is also written in GAMS. So I'll take up these problems which are solved. Okay. So this is how it is written in GAMS. So now I will share another screen where I will show you that how the program is written. Sanjeev, this window is visible to you?
Visible, sir, visible.
Visible. Okay, fine. So now what will you do? You install a GAMS software in your PC. Okay. So this software, once it is installed, this will look like this kind of the sign you will get on a screen. So double run it, double click it. This will open, and window will open, and then you can call a program where you have written. Like I talked about the one important problem to you, how to write it, which is called as a salesman problem. How to find out how to send a quantity from a plant to the cities. I have written it in my own way. I show you that the city can be written by their name. It can be written by, there are 2 cities, there are 3 cities and 2 plants. So I'm writing it as there are 2 plants, 1, 2, 2, and markets are 1, 2, and 3. Capacity I'm defining by this AI. Then demand I'm defining by this. Scalar freight in dollar I'm defining by this. Then variables, there are 2 variables here, X and Z. X is very positive, I'm declaring it. This is a equation, 3 equations. I am declaring these equations. Declaration is very important. Then I'm writing this equation in a very simple syntax of GAMS. Then model statement, AK is a program name. Solve AK, LP, minimizing Z, display values. So once this program is translated into GAMS, now run it. This window will appear. Now you can find out that here, if you have not selected a solver, it will ask which solver you want. I have already selected a solver, but first time if you use, it will ask what kind of solver you want to use. Then you can click it, which kind of solver. Okay. Now it has run. So this is a listing file you will get. This is a listing file, list file. This is giving entire details of the program. Because this program is correctly written, it has successfully run. So you will get a solve summary here. Solve summary, what is the objective function, normal completion, optimal. In solve summary, you must get solver status normal completion. Only then you will call that program written is correct or solution obtained is correct. Model statistics says that it is optimal. This is the objective value. Level values, marginal values, you will start learning later. Okay. These are the marginal values. Okay. So 0 infeasibility has to be there. Okay. 0 unbound has to be there. 0 non-opt has to be there in a report summary. This is a correct running. It has given an optimal solution. It has given an optimal solution. So this is a first program we are talking of. Second, this I talked about. The problem taken from S. Rao. Variables were X1, X2, X3, and Z. So write it in a GAMS program. There were 4 equations. So I've just translated them into GAMS. So once all this is ready, call model. This is the name of the program. Call a solve. NLP, minimizing Z. Run it. So this has run, and successfully there is a normal completion status. Okay. And you can find each and every information in this listing file. How many blocks of equations, how many blocks of variables, how many non-zero elements, how many derivative pool, what is the code length, each and every information, what is the time of solution, and solve summary. You will get solve summary here. Okay. So very good information you will get out of the listing file. The third problem which I designed for you is the dispatch problem, economic dispatch. Least square problem is also there, which I've taken from a book as Rao, which is also solved here. Economic load dispatch we can talk of. So this is a comment set. Yeah.
Sir, I request to please wind up and please send us the presentation.
Okay, fine. Thank you.
And
So, Dr. Sanjeev,
you can also send, if these problems are, can send us the problems also in a
I will
separate
send you all
attachment.
the problems which are designed for this lecture today.
Yeah,
That
as
all
an
the
attachment.
they know how to write.
Yeah.
So once the program is ready, you can run it, and you can find optimal solution, and you can find out from the listing file that GAMS has run successfully, completion is normal. Then you can find out what is the objective function, locally optimal. Likewise, you can use many other solvers for finding out the solution.
So
So, Dr. Sanjeev, I end my presentation
Yes.
here.
Yes, sir. Yes, sir. Thank you, sir. So I thank Dr. Ashwini for valuable inputs, and he has provided the information regarding this GAM software, which is very helpful for solving power system optimization problems. And major power system consultants use this software for developing solution for power system problems. So I am hopeful that this information will be useful for the research students and the faculty who wants to deal with the power system optimization problems. So
Yeah,
I
Dr.
thank you.
Sanjeev, we have developed a lot of codes in GAMS, especially for the power system optimization problems, which looks to be very rigorous. However, there are certain statements like loop statement, ORD statement. This will be known once you are starting using it. So I request, first of all, you solve simple problems, then you go for the complex problems. Yeah.
So
If you need any kind of help, any kind of code for load flow studies or for fax devices placement, so many codes are developed, and I can share it with you if any student is interested.
sure, sir. Sure.
Okay.
So
So thank you very much.
With
Namaskar.
this, I thank Dr. Ashwini sir and all the participants, and the session is ended now.
So thank you very much, and have a nice day.
Thank you, sir. Thank you.